reach out and get some help. I cannot minimize Zoom. I'm recording the meeting. Okay, so I asked you guys to do questions 6 and 7, and I'm going to go do 6 in Excel because we can, right? We can use Excel when we're taking the midterm and the final, when we're doing our homework. And why would you not use Excel since everything in the real world is going to be with spreadsheets, right? So let's go ahead and put this information in here. We've got fixed cost, variable cost, total cost, average fixed cost, average variable cost, average total cost, marginal cost. We can move this guy down here. Wait, you got to do that first. Move down to 600. Awesome. Let's go ahead and increase the font so you can see. And as table, just like that. Tables, headers. Awesome. Okay. So now we are told the fixed cost is 15,000 buckaroos, right? All of these amounts are going to be dollars, so I can go ahead and just format them right now, dollars, and get rid of the decimals. I hate seeing decimals. Okay, so then we've got our average total cost we're given. We got a dash here, right? Because there's no average total cost when the production is 0, right? And then what do we have? We've got 300, 200, 175. 175, 225, 325, 400. All right, so now we are asked to fill out the rest of it, essentially, right? So we know the fixed cost is going to stay the same regardless of the quantity. That's by definition. We're given the average total cost, so we can use a formula, right? Since average total cost is equal to total cost divided by Q. If we multiply both sides by Q, we get total cost is equal to average total cost times Q. And so that's exactly the formula that we are going to use right here. We're going to say average total cost times Q minus. I was right, G was wrong. All right, moving on. All right, so average fixed. So now we can do variable cost by using our formula for total cost, right? So total cost is equal to fixed cost plus variable cost. So variable cost is equal to what? Total cost minus fixed cost. So we're going to use that formula right here. This formula over here. So this is going to be total cost minus fixed cost. Bada bing, bada boom. All right, so then we're going to calculate our average fixed cost. Average fixed cost, we know the formula for average fixed cost equal to fixed cost divided by quantity. Any kind of formula that has average, you just take whatever is afterwards and you divide it by quantity, right? And so we're going to do this is equal to fixed cost divided by quantity. And then we're going to double click and it's going to fill out the rest. Oh, yeah. Now what about average variable cost? Average variable cost, same thing, is just going to be variable cost divided by Q. So this is going to be equal to our variable cost right here divided by our quantity. Now our last one that we're asked, I messed up here in terms of, that's a part of it too, but whatever, not a big deal. Marginal cost, what's our formula for our marginal cost? That's going to be the change in the total cost. Total cost, this one minus the previous total cost. We're going to put that in parentheses. And then we're going to divide by the change in the quantity, right? So then we've got quantity minus initial quantity. So this is going to give us an error at first because I've got a dash here. I'm just going to put 0 in there because then it actually works. Let me just Okay. Oh, it didn't work. Format. Can I? Okay, wait. I'm going to clear all the format. Where's that button? do it. I want this part to be formatted too. Okay, it doesn't matter. I can make it big at least. All right, and then we're just going to drag this to get the rest of the marginal cost, and we can spot check, see what it's doing, right? It's taking 90,000 and subtracting 52,000 from it, and then it's dividing by 400 minus 300. So are these all the values y'all got? Any questions on this? So I highly recommend you use Excel to do this. It may be difficult for you at first, but it is the most important business application around, most robust. And I highly recommend you get them. Moving on. Questions? What's that? Okay. If it's not a test, I'm gonna allow it. But no smelly food during any test. Oh, we don't have any tests here, so we're fine. There was this one time I was like, not feeling that great, not from drinking, and then I had to take a midterm the next day, and there was a guy with a really smelly onion mustard sandwich, and yeah, it was distracting the whole time. It was terrible. Okay, moving on, page 169 of chapter 6. Number 7, we're given a multi-product firm's cost function. Focus. Multi-products. Either Dallas multi-products. Firm cost function. Recently estimated as C of Q1 comma Q2 is equal to 90 minus 0.5 Q1 Q2 plus 0.4 Q1 squared plus 0.3 Q. So we are asked, are there economies of scope in producing 10 units of product 1 and 10 units of product 2? So whenever we're asked, are there economies of scope we're going to check if this formula is positive. If F minus A times Q1 times Q2 is greater than 0. So in this particular case, the F is this 90. The A, anybody know what the A is? Negative 0.5, very good, G. And what's our Q1 and our Q2? 10 and 10. So we're given that in the prompt, right? We're told Q1 is equal to 10, Q2 is equal to 10. I just failed to write it down. I'm sorry. Q1 equal to 10, Q2 equal to 10. And it says in the prompt when that's happening, right? Because it's going to differ depending on where you're at in the production process. All right, so let's plug this in. 90 minus negative 0.5 times 100 is absolutely greater than 0, right? Because this negative, positive, 0.5, 100 is 50, 90 plus 50 is 140. That's greater than 0. Big check. So because of that, therefore, that's what a double arrow means. Because of that, economies of scope exist. And yeah, that's questions on that. So we literally just pluck numbers out of the formula and check them. At the end of the day, what is it really checking? It's checking, this is the shortcut for is C of Q1 0 plus C of 0 Q1 greater than producing both of them together. C of Q1 comma Q2. So is it the fact that producing them independently is more costly than producing them together? That's we can do the long way and actually calculate these things, calculate the cost of it with Q1 is equal to 10, right? So this would be, for our example, it would be 10, 0 plus C of 0, 10 needs to be greater than C of 10, 10. Does that make sense, everyone? And so the F minus A times Q1, Q2 greater than 0, that's just a shortcut. If you were getting your master's in like applied economics or something, you probably need to know the proof. But you're not, so you know. You just gotta know how to use it. So questions on that? So it will be fairly straightforward in the midterm and in the quizzes in terms of, you know, asking you using the same kind of language and giving you Q1 and Q2. Now, we're also asked about cost complementaries. What are they talking about with cost complementarities? So this is, again, page 169 of chapter 6, number 7. This is B now. And we're asked, are there cost complementaries in producing goods 1 and 2? And so what does it mean when it says cost complementaries? How does a cost complementarity emerge? Go for it. Very good. Yes, perfect. So let's write that down. So they exist when the marginal cost of producing one good decreases when the output of another good increases. So in math, because I know y'all love the math, that means a change in the marginal cost of one good is going to decrease, so it's less than 0 when we increase Q2 by 1. So that's the math way of saying it. So if and only if, that's what a double arrow means. Cost complementarities. Exists if and only if the marginal cost of one of the products decreases when the output of the other good increases. So we could go ahead and calculate the marginal cost and, you know, divide, but why? Because of course there's a shortcut formula for this one as well. So before we wrote out the, what am I going to do here? I'm going to do C, Q1, Q2 is equal to 90 minus 0.5 Q1, Q2 plus 0.4 Q2. Actually, that's just one squared plus 0.3 Q2 squared. So I color coded this stuff because at the end of the day, the only real important stuff is the, so this is also, we can think that the generic form is equal to the F plus A, and then the rest of the stuff we don't care about, essentially. Q1 times Q2 plus Q1 squared plus Q2 squared. So what this is telling me is the fact that these things don't actually matter. So these numbers over here, right, they're not given, there's no representation down here for them in the same way that there's representation of A and there's representation of the constant as F, right? So the only thing you really gotta kind of pull out of the information of these multi-product cost functions is the constant and the coefficient that's multiplied by the cross product term, Q1 times Q2. Make sense? Okay. So all of this to just say that when A is less than 0, cost complementarities exist. Backwards E just means exist. When A is greater than 0, cost complementaries don't exist. So in our example, do cost complementaries exist? Yes, boom, easy question. Literally just have to look at the equation and just kind of parse it, right? Be like, oh, the negative. Yeah, cool. Cost complementaries exist. So do we understand the kind of intuition behind why that is, right? When A is less than 0, an increase in Q2 reduces the marginal cost of producing Q1. So when we take the marginal cost, well, I guess, okay, you guys don't want to do the calculus of it, and it doesn't matter, so let's move on. I'm learning my audience. Questions on this, though, before we move on? All right, cool. We should talk about economies, diseconomies, and constant returns to scale. So, just some definitions real quick. Economies, of scale, means there's a, Christian, what are you whispering about back there, man? I got ears like a cat. Portion of the long run. We'll take your Adderall, man. Come on, get with it. Average cost curve as output increases. So essentially what happens is, in the long run, all costs are variable, right? So in the long run, it sounds like the start of a lore. In the long run, all costs are variable. And that's because the manager can adjust all the stuff, right? You know, even the size of the building. Or the amount of machinery, right? So there's actually, he can choose between different average total cost curves that relate to essentially different amounts of fixed capital investment. So now we have a long run average cost curve. And this is, of course, measured in dollars. We've got output measured in units. And we end up with, you know, an ATC curve that's over here when there's not a lot of investment, an ATC curve that's over here when there's a medium amount of investment, and an ATC curve that's over here when there's a high amount of investment. And because they're choosing between all of these different ATC curves, and there's more than just this, I just wrote 3 of them, right? But essentially there's a whole bunch of them in between. And so what we call the outer envelope, that's a term you don't need to know, but it will make you sound smart around math majors. The outer envelope of all of these things ends up becoming the long run average total cost curve, right? So I'm not going to draw right on top of it because I don't want to ruin my Sharpies, but this should actually be right on top of it, but I'm just going to represent it as an outer envelope, right? So this is my long run average total cost curve. And it's sometimes the T's out, so it's just the long run average cost curve. But does that make sense how it's the outer envelope of all of these? Because like essentially he can adjust his physical capital as much as he wants to whatever granular degree he or she wants. So going back, so now that we have all of the capital available, to, you know, it's all adjustable now. We can, you know, figure out where we should be in this curve to get the greatest economies of scale, right? Where there's a declining portion in the long run average cost curve as our output decreases. So it's going to be all of this. So let's redo this graph. And any point to the left of its nadir, its lowest point, right? All of this is economies of scale. Oh, sorry. So all of this area here, right? So any of these points here, they're all economies of scale, right? As you're increasing production, that long run average total cost decreases. And then over here, this is all diseconomies of scale. Any point along here as we increase the quantity, 120 to 200, the average total cost is going to increase. All right, before we move on and do a Leontief production function, I need somebody to explain to me the difference between fixed costs, sunk costs, and variable costs. Can you explain one of these things for me, Priest? Yeah, I come to class prepared to get participation points. You can do it. What's up, Don? Changes when it's question number 8. Sunk costs is what? Past costs. So they're forever lost. We can't get them back. Forevermore. You cannot get them back. Ever gone once they've been paid. So this is why when I go to a movie, if it sucks, I leave. I leave. Sunk costs. I can't get it back, but I'm wasting my time, and they never get better. My gut's always right, you know? So I've walked out of like 30% of the movies I've seen the last like 10 years. I just fucking, I just leave. And maybe I'll see it on HBO or something like that later, but you know, like it's a sunk cost. Like I can't, you know, I can't get it back. But I can optimize my future and I can leave and go do something else and go watch anime at home. It's usually better. So we're not supposed to think about sunk costs when we make economic decisions, right? So, you know, if something's in the past, if you can't get it back, you're supposed to essentially pretend like it never existed. Now, in reality, a lot of us actually, you know, we do include sunk costs in our decisions, right? Because, you know, we're like, oh, well, we spent all this time on blank, and so now we need to finish it. When in fact, we should finish it because it's rational looking forward based on how much effort and cost I'll have to do to get it. It's rational because the benefit that I get for it is still greater than the cost. Does that make sense? But essentially, the kind of economics that we're learning, psychologists, like the economic model of a human being that we've made up, Homo economicus, psychologists see as like a sociopath. So it's not very representative of reality. It's a mechanism that we use. Behavioral economics is a really great book for anybody that's interested. It's called Nudge by Nobel Prize winning Richard Thaler. I highly recommend it. It talks a lot about the ways in which we do include sunk costs in our analysis, and the way in which businesses, people, governments can kind of nudge people to make, you know, a better decision or a more rational decision by the way that you lay out the choices. So it's about decision theory and choice theory. What's up, Dom? It means like, so a nudge is, it comes from like a physical thing, like kind of a poke, right? But for this, it's more like, instead of having you opt into something like a retirement program or whatever, it has you automatically opt out. And so that's a nudge to get more people to save for their retirement, right? Or like the nudge is, instead of offering just two options, like a low price and a high price, you offer a low, medium, and a high. And because there's a low and a high, a lot of people will choose the medium price or the medium tier of something, right? So those are nudges as well. Yeah, absolutely. It's a fascinating book. Okay, number nine. Firm produces according to the Leontief production function of Q equals F of K and L equal minimum of 4K and 8L. How much output is produced? This is A. How much output is produced when K equals 2 and L equals 3? Someone who doesn't talk today. It's okay. You talk. Savannah? What's the quantity when K equals 2 and L equals 3? So that's what a lot of people think at first, because it seems like you would take the minimum of this one or this one, right? And since 8 times 3 is 24 and 4 times 2 is 8, that's going to be it. When in fact, this is aggravating, but the way we unpack this is Q is equal to 4K plus 8L. So it's going to be, oh wait, hold on, that's 10. Okay, that makes way more sense. It's absolutely 8. I was like, what is going on here with the guy? Yes, it's 8. So how did we get to 8? We got to 8 because we took 4 times 2, and then we compared that to 8 times 3. And then we compare these two numbers, and whichever one's lowest is the minimum, right? So we're trying, which one's the winner? 8's the winner. As a result, it equals 8. So since the Leonti function is you need as much capital as you do labor, we're going to be, for this particular instance, we're constrained or bottlenecked by the amount of capital that we're employing, right? So we have all this extra labor that's not doing anything. So we're not at that, what we would call a kink point in the, we're not here, we're somewhere, hold on, it's on what axis? Capital is on this one, labor's on this one. So we are not right here, right? We're somewhere over here. So we're over employing capital labor and we need to get rid of some. Yes? There is no maximum one. So there's 3 types of production functions. There's the one where there's the exponents, the Cobb-Douglas, which is by far the most common one. There's the simple one, which we'll do in question 10, which is where we just add them up together, the one-for-one substitutability. The exponents is when there's substitutability, but it's not one-for-one. And then this one, there's no substitutability. So for a certain amount, right? And that's why we have all the different curves, right? This one has to do with producing 8 units. If we had a little bit more capital, we could produce 9 units, right? By jumping to a new curve. So this is the weirdest one. Does that make sense now, Gene? This is the weirdest one. And you don't need to conceptually understand it. You just need to be able to unpack it. I mean, it'd be nice to conceptually understand it, but it's not required. I'm not going to ask you conceptual questions on this. It's going to be exactly like question. So, what is the, go back to page 169, we're asked if the wage rate is $60 and the rental rate is 20, what is the cost minimizing input mix to produce 8 units an hour? All this is per hour too. And again, the F for this guy is min 4K 8L. So our wage is a lot more than our rental rate, right? So are we going to necessarily be multiplying 8 times? Okay, so we'll have to do at least 8 times L. how much K will we need in order to get 8? 2. So essentially we set this equal to 8. And then we also set this equal to 8. That's our cost minimizing. And that, here, we'll do it again. We'll do it again. That'll get us to this point, right? Because again, right here, we were at, how much labor were we using? We were using 3 labor, and we were using 2 capital, right? And we were over here. We need to get right here. Does that make sense? So the cost minimizing input mix to still produce 8. So we need to decrease the labor from 3 to 1. This is extraneous information for this part. I apologize for that. That's right. Oh, and it's because it's trying to trick you. So it asks in the next question, how does your answer in part B change if the wage rate decreases? And essentially, it doesn't. Since K and L are perfect complements, the cost minimizing level of K's and L do not depend on the rental rates of K and L. So this crap is straight up just extraneous for all of it, and I will go through and take out questions that are trying to trick you like that on the midterm. But it's good that we know, essentially, like, the cost, since they're perfect complements, we need what? We need 2 units, we need 2 units of K for every 1 unit of L. So it doesn't matter if the wage rate dropped or the capital rate increased or anything like that. In order to make 8, we just need 1 unit of labor and 2 units of capital. So now let's do a linear production function. Let's do number 9. Oh, sorry, 10. 10. All right, so Q equals F of K and L equals 4K plus 8L. What is the output when K equals 2 and L equals 3? We literally just plug and chug. 4 times 2 plus 8 times 3. 8 plus 24 is equal to 32. 32. And then we're asked if the wage rate is, is there any question on that? Wage is 60 per hour, rental is 20 per hour. What is the cost minimizing input mix for producing 32? So same thing, but now we're actually going to be using that information. So the first thing we need to do is calculate the marginal rate of technical substitution between capital and labor. So that, in this particular example, is going to just be this 8 divided by this 4 is equal to 2. So that means, what does this mean in English? The company can trade, very good, or sorry, 2 units of capital. It's okay, we all get a little dyslexic sometimes, for 1 unit of labor. It's 4K plus 8L, yep. They can trade 2 units of capital for every 1 unit of labor. yeah, yes. Sorry. Yeah, so page 150 is where this is all defined. This is the MPL over the MPK. So the marginal rate of technical substitution is the marginal product of labor over the marginal product of capital. And so we do, you guessed it, a partial derivative. So it's really just the coefficient on labor divided by the coefficient on capital. And so for this one, there's no diminishing marginal rate of technical substitution. It holds at 2, it's constant. Right? There's no, it doesn't change like with the Cobb Douglas one. So it's a constant. There's perfect substitutability. Between capital and labor. We can see that from the equation and also just from the what a linear production function is between, capital and labor. So therefore, only one input will be utilized. The difference between used and utilized. I always forget to look at it. Utilized just sounds like a snotty way to say it. So at the end of the day, so this definition was on page 147 of your text. And then on page 150, we're given our cost minimizing input rule, which is marginal rate of technical substitution of K and L should be equal to W over R. Oh wait, that's for, sorry, that's for Cobb Douglas. So don't use that. Let's just stick with this one. So this is our rule. This is our kind of golden rule. But we're not going to be able to set it equal and solve for stuff because essentially we don't have any variables going on with this, right? We've got so here let's take this apart for a second. So what's the marginal rate of technical substitution again? It's the marginal product of labor over the marginal product of capital. So if that's supposed to equal, or if that's supposed to be the W over R, we're trying to figure out what's going on here. Then we can look at what is the particular, we can do a little swap here. No, we don't want to do that? Okay, how about we do something, hold on. Let's look at what's the marginal product of labor divided by the wage? And is that greater than, less than, or equal to the marginal product of capital divided by the rental rate of capital? And so that's going to determine what we use, because essentially this is telling us the marginal product per $1 spent on it, and this is telling us the marginal product per $1 spent on rent. And so the marginal product of labor we know is 8. We're told the wage is 60. We're given the marginal product of capital is 4, and we have a rental rate of 20. And so 4 divided by 20 is greater than 8 divided by 60. And so as a result, we should use all capital. 32 output, you literally just take the capital part of the equation, right? It's going to be f of k and 0 equals 4k plus 8 times 0. This goes away. So then in order for that to equal 32, we just divide both sides by 4, and we end up with 8 equals k, right? 4 times 8 is equal to 32. So we hire 8 units of capital. So we're looking at the relative, right? We're looking at the marginal productivity of capital divided by the cost of capital. And we're seeing is that greater or equal to the marginal product of labor divided by the cost of the wage. If it is, then we're going to only use capital. And the reason why we can do that is because it's a linear function, right? There's perfect substitutability between the two. So now, I know we're late, but what do you guys want to do by Friday? You think, so we have, so this is chapter 5. We don't have chapter 6. We're almost through chapter 5. There's probably, there's more practice and stuff for you guys to go through, but in terms of types of questions, I don't have too many more to go through. So I believe we should be able to finish chapter 5 within the first 10 minutes of class on Monday, then do chapter 7, and then have Wednesday for questions. Does that make sense? Okay. So let's cancel class Friday. Okay. All right. Cool. But wait, hold on. I want you to do before class on Monday. What if wage rate decreases? What if it's now $20 an hour? And what if capital rental rate stays at 20? What's going to happen now? Are they going to keep on using capital for production? So this is part C of 10. All right, so coming to class prepared, talk about that Monday. What if wage is 20 instead of 60, right? Wage used to be 60. Wage old is 60. Rental old is 20. So rental is staying the same, right? But the wage is changing. And so how's that going to change the mix of output and capital we use to minimize our labor input cost and get that 32 units of production? Good job. You're doing great, buddy. You're crushing it.